McLaren, we're on to the last of our series of electrolysis of solutions, and this is the electrolysis of sulphuric acid. So, how are we going to tackle this one? Are we running into a theme now about how we approach these questions?
Sulphuric acid, well, we know it's ionic because all acids in solution contain hydrogen ions. So I suggest we do the same format.
Okay,
Why
let's work out the ions.
Ions present.
Right.
So, shall I do that, Dr. Bourne?
You do that. Ions present in sulphuric acid.
So sulphuric acid, the formula is H2SO4, it's aqueous. So the ions present are hydrogen ions from the acid, sulphate. Now because it's aqueous, we could put the hydrogen ions, I'm just going to put the hydrogen ions in from the water.
Lovely.
And hydroxide
Excellent.
from the water.
So then we have to decide what's going to be attracted to the negative cathode.
Excellent. Well, those are known as cations, and there's only one positive ion there, so it's very, very straightforward. Dr. Bourne.
That makes life a lot easier.
Yes, and it is the hydrogen ions.
Hydrogen ion. So lovely. So let's look at the anode. What's going to be attracted to the anode?
So the anode will attract anions, and those will be the negative ions. So it will be the sulphate and the hydroxide.
Okay, so we'll come back to those in a minute. The cathode is clearly going to be easy because there's only one thing that could possibly be discharged, and that is the...
I think, let me guess, it could be hydrogen.
Well done.
Let's see.
Now, can you do the equation for what is happening at the cathode?
I think I can manage that, Dr. Bourne.
Okay, and now you have to
H
remember...
Hydrogen is a diatomic molecule, so
Goes
we have
round in
two
pairs.
hydrogens.
Okay.
So we've got 2 plus, and it's 2 plus, it gains 2 electrons from the cathode, which means your hydrogen ions have been reduced
Reduction is gain.
to hydrogen gas.
Lovely. So let's look at the anode. A bit trickier. We've got to remember our rules. So what are the rules for discharge at the anode here?
Preferential discharge means halide before hydroxide before any other negative ion. There's no halides there, so therefore it's hydroxide which is preferentially discharged.
Now, if I remember, that was a tricky equation, but we had to remember the products. So what are the products?
The
Mr.
products
McLaren?
are oxygen, gas, and water.
Lovely.
And in order to balance this one, Dr. Bourne, all you do is put a 2 in front of the water.
Right.
Now that means you get 2 oxygens plus another 2 oxygen gives you 4.
And you've got 4 hydrogens.
So you multiply that by 4.
Lovely.
So everything's balanced there.
Good.
You have 4 negative, which means it needs to lose 4 electrons.
Right, where are
to
they
the
going to go?
anode.
To the
And you
anode,
need
so
to
they'll
put
be
them
over there.
this side.
Okay.
And you can see the hydroxide ion has been oxidized because it's lost electrons.
Oxidation is loss. The final thing we have to do is think about our observations. So you have to look at your products, think about what's being produced and what would that look like. So
for the cathode, hydrogen gas is produced, so you just say bubbles of colourless gas.
lovely. So we don't have to name the hydrogen when we're talking about observation.
No.
You just describe it.
You describe it, so
Perfect.
really it would be bubbles, colourless gas.
Okay, excellent. What about the anode?
The anode, here the most obvious thing would be the oxygen gas, and again that would be bubbles of colourless gas.
So although they're different gases produced, it's going to look exactly the same. So when we electrolyse sulphuric acid, we get 2 gases given off, and they're both going to be colourless. Is that
That
right?
is correct.
Oh, well, that was very easy.
Well, I think we're sorted on electrolysis of solutions,
Absolutely
Dr. Bourne.
sorted. Thank you, Miss McLaren. That's
Perfect.
done.